Percent composition and popcorn. This is the virtual pre-lab activity. You should have already updated your lab list. If you have not, check the student directions. You are beginning with this pre-lab and you're going to need your reference tables. So you should have this pre-lab handout and you should fill out the top. Remember, for the lab period, it's going to be A or B. Now, you're going to complete the pre-lab handout with your group. This video provides some assistance. If you complete this video with the Play Pause It version, you can earn 40 minutes for the virtual lab, okay? You must show work in order to earn minutes. Remember, if you're absent, if you're sleeping, if you're not participating, if you're on your phone, you're simply not going to earn those minutes. You have to be in it to win it. All right, first we're going to be reviewing gram formula mass. Okay, we're going to do this one right here, and this is about as simple as it gets. All it is asking me for is to find the gram formula mass or molar mass or formula mass. Those all mean the same thing for just this. This is one singular element, remember, one capital letter. Here's its exact match on the periodic table. There are no subscripts. So all I'm asking is, what is the mass of 1 mole of this? Okay. Now, if I'm looking right here, this on the periodic table is labeled as atomic mass, meaning the mass of 1 atom of sodium. And I want to round it to 1 digit after the decimal. So that means I keep the 2, I keep the 2, and then I decide if I keep the 9 or round up. I look to the digit immediately to the right. It's an 8, and it tells me to round up. But here's what I have, 22.9, and when I round it up, the 9 becomes a 10, so it rounds up to 23.0. Now, if I'm talking about an atom, the units would be U, atomic mass units. But when I'm being asked for gram formula mass or molar mass, I want the mass of 1 mole. And remember, that means 6.02 times 10 to the 23rd particles. So the mass would not be this because this is the mass of 1 of those particles. So what is the mass of Avogadro's number of particles? Well, guess what? It's kind of easy. It's just this same atomic mass. We just changed the units. So it's 23.0 grams per mole. Okay, and then on your paper, it says you have to circle your right answer. I've kind of been circling as I go along, so I'm just going to differentiate. This is my final answer for sodium. All right, now let's look at this one. We have, this is aluminum oxide, so I'm doing this one right here. Okay, now you can see I have 2 different elements. I have Al, here's its match on the periodic table, and then I have oxygen. And here's its match on the periodic table. But I have subscripts. So how many aluminum atoms do I have? 2 times something. Oxygen, I have 3 times something. Okay, so what about for aluminum? This is its atomic mass, which remember is the same as its molar mass. I just changed the units. Okay, and I want the 2, I want the 6, and then I decide, do I keep the 9 or do I round it up? Look to the 8, you round it up. So that's going to be 2 times 27.0. I don't need to write that. Okay, and 2 times 27 is 54. Right, now what about oxygen? Right, again, I need to round this. 1, 5. There's the 9. Look at the next digit. It's also a 9. I round up 16.0, or I can just write 16. 16 times 3 is 48. What does this mean? That means the mass of the aluminum part is 54. The mass of the oxygen part is 48. So how do I find the gram formula mass or the molar mass of the whole thing? I add these 2 together. Okay, so I add 54 and 48, Okay. And so that's 12, carry the 102 grams per mole. Okay, and then remember I need to circle answers. There we go. Okay. You are going to have to do 2 more calculations on your own, this one and this one. Remember rounding the atomic masses from the periodic table to 1 digit after the decimal. All right, next is calculating moles. We need the mole calculation formula. That's on the back of your reference table, also seen right here. Okay, how many moles are present in 27.2 grams of NaOH? So here, remember, is the mole formula, but I'm just going to write it a little bit abbreviated. So I'm just going to write moles equals mass is grams and gram formula mass is just GF. Okay, so when I look at this question, I see that I have this number, right? And it says grams, so I can put that in place of G. Also, I know I'm solving for moles, so I'm going to leave that moles equals, and I'm going to put 27.2 in place of the grams. Now, I'm not going to be able to solve for moles unless I have a number for gram formula mass, right? So we just did that. We figured out gram formula mass. All right, so I'm going to have to do that for this. You can see how many NAs do I have? 1. How many O's in the formula? 1. How many H's in the formula? 1. So I just need the atomic mass for each of them, remembering to round it to 1 digit after the decimal. So we have 23. We have 16, and we have 1. And then I add them all up. So 16 plus 1 is 17, and then 17 plus 23 is 40 grams per mole. Okay, now I put that 40 down here. Okay, and then I do the math. So let's pause for a minute. When I do that math in the calculator, I get 0.68. And normally I'm going to be rounding to 2 digits after the decimal. So I already have 2 digits after the decimal. So that means I'm finished, and I was solving for moles. So remember, we don't leave naked numbers. We put units. And then remember, I'm circling my answer. Okay, you have one more problem to do. Remember, you round atomic masses to 1 digit after the decimal, and your final answer to 2 digits after the decimal. Next is calculating grams. And for this, we use the same exact formula, okay? Now, I use the same substance just for ease of calculations, okay? So how many grams are present in 8.23 moles of NaOH? Okay, so again, I'm using the mole formula, but I'm going to rewrite the formula, and I'm just going to write it simpler, right? So moles equals grams over gram formula mass. Okay, so what number do I have in the question? 8.23. The units are moles. So in place of moles, I'm going to put 8.23 equals, I know it's asking me to find grams, so that's going to be my variable, right? So then I need gram formula mass. Well, I just did that in the last problem, right? So that's why I didn't switch the substance. So we didn't have to find the gram formula mass again. We just did it, okay? Now, I do not encourage students to rewrite the formula. I'm just going to do it the easy way, which is let's set it up to cross multiply. So I'm going to put this over 1. Did I change the amounts? Absolutely not. I can divide anything by 1 and it's the same thing, right? But now I can cross multiply. So I'm going to see that my answer is going to be 8.23 times 40. And that is going to equal 1 times gram, which is just grams. Okay, when I do that in the calculator, the answer that I get is this, 329.2. Now, it doesn't have a lot of excess digits, so I can just use it as it is, okay? And I was finding grams, so there I need the units, right? No naked numbers. So the units are grams, okay? This is my final answer. Okay. Now, what if I had to put it? So if I was typing my answer into a program and I had to have 2 digits after the decimal, well, my answer would just simply be 329.20 grams. That's it. I didn't change it. I could add a 0 after a decimal and not change the value, just change how many digits there are. All right, you have one more problem to do. Remember, you're rounding atomic masses to 1 digit after the decimal, but your final answer to 2 digits after the decimal. All right, next is calculating percent composition. Okay. We have a different formula for percent composition, but it's also on the back of the reference table. Okay, what is the percent composition by mass of nitrogen in NH3? Now it gives me the gram formula mass, but I'm just going to do a quick reminder. So when I look at this formula, there's 1 nitrogen times 14. There's 3 hydrogen times 1. So when I add 14 and 3, I get 17. Why did I want to take a moment and do that? Well, because we've talked about it before, but this 14 represents the mass of the nitrogen part of the formula. And this 3 represents the mass of the hydrogen part of the formula. And that's the concept you have to understand in order to do the calculation. Okay, so I'm just going to write the percent equals mass of part over mass of whole. And I cannot forget the times 100. I will get the wrong answer if I don't do that. Okay, so what do I do now? Well, when I just went through it, remember, this is the mass of the nitrogen part. This is the mass of the hydrogen part. Go back to the problem. It says, what is the percent composition by mass of nitrogen? So that means the part is the nitrogen. And what is the whole thing? Well, the whole thing is the gram formula mass. And then I multiply that by 100. Okay. All right, what I'm going to get when I put that in the calculator is 82.3529. Okay, I'm going to stop there. And again, I want to round to 2 digits after the decimal. So keep, and here's where I'm deciding. I look to the next digit. That does not tell me to round up. So my answer will be 82.35%. Okay, now I'm going to circle my answer. Okay. All right, you have another problem, same type to do. Okay, remembering round your atomic masses to 1 digit after the decimal and your final answer to 2 digits after the decimal. Okay, next is determining greatest percent by mass. So this is conceptual, and you don't actually have to do all the math typically. I mean, you can, but that's just more work, okay? So we could use the percent composition formula, and you could find the percent composition for each of them. But I'm kind of going to show you a short way to go through this. All right, are you ready? All right, so this is the one that I'm going to look at, okay? And it says, which compound contains the greatest percent of manganese by mass? Okay, so if I look, each of these has one manganese and then different amounts of oxygen, okay? So I am going to break each of them down a little bit, but I don't need to do all the math, okay? So let's look here. So we have Mn, MnO2, and MnO3. All right, so let's look. What is the atomic mass of, this is manganese. It is not magnesium, it is manganese. So the atomic mass of manganese is 54.9. Okay, that's the same in all of them, right? So in this one, it's 54.9. And in the last one, it is also 54.9. All right, so the only thing that changes then is the oxygen, all right? Now this has one oxygen, so that's 16. So for this formula, the manganese is 54.9 of the grams, and the oxygen is 16. In this one, I don't have one oxygen, I have two. So 16 times 2 is 32. So this manganese part is 54.9. The oxygen part is 32. And in this one, I don't have one or two, I have 3 oxygens. And 16 times 3 is 48. Okay, so the manganese is 54.9 grams and the oxygen is 48. So this says, which compound contains the greatest percent of manganese by mass? So if you think about it, the gram formula mass would be adding these two together, right? And then to find percent composition, I would take the manganese part and divide it by the whole thing. Okay, so that means I want the manganese part to be big and the oxygen part to be small. Well, if in all of these questions, all of these compounds, the manganese mass is the same, then all I want to do is pick the one where the oxygen part is the smallest. Now, if I went through and did all the calculations, I would find out that's the truth, but it's not necessary. I can tell that this sample right here has the greatest percent of manganese because its percent of oxygen is the smallest, okay? Now you have another example to do here. Remember, rounding atomic masses to 1 digit after the decimal. And when we're calculating final answers, we want to round to 2 digits after the decimal, okay? Now you should be finished with the pre-lab because it was just that front of the paper. In this lab, we're going to be looking at popcorn, and we're going to apply this percent composition concept to popcorn. Okay, so what do I mean? Well, I mean here, if we have a popcorn kernel, there are different components of the popcorn, and they all add up to the total amount. Okay. So what you may or may not realize is part of popcorn is water. So when we heat popcorn, it pops. And as it pops, water is released as steam. So if you notice when you open a microwave bag of popcorn, some steam does escape from the bag. Okay, where did that steam come from? Well, it came from the popcorn itself as it popped. So the popcorn kernels have more water in them than the popcorn after it's popped because some of it escaped as it popped. So that means after popping, the mass of the popcorn should be less. Okay, so if I took one popcorn kernel and measured its mass, and then took the same popcorn kernel after it popped and measured the mass, it should be less because some of it was released as steam, water vapor. The law of conservation of mass says that mass must be conserved. It cannot be created, it cannot be destroyed. The mass then was not lost. So even though we started with a higher mass and end with a lower mass, it was not lost. It didn't disappear. It wasn't created. It wasn't destroyed. Some of the mass was simply converted to steam. And when we open a bag, it escapes into the air. Reminder, if you need to make up lab minutes, this must be completed as a play posit, and you need to score an 85% or higher. Lab groups should be bringing up their pre-lab handouts to be checked for completeness and for accuracy. Remember, I walked you through some of the problems, but not all of them. You had to do some of the calculations on your own, and then minutes will be awarded. When the pre-labs are returned to you, you will get the lab handout, and that will allow you to continue. Okay?